Okay, good morning class. So today we're looking at analytical geometry. Have we done any recordings of this yet? No. Are you sure? Okay, so as it stands, we haven't made any recordings yet, but we are on exercise 11.3. We've done 11.1 and 2. We're experiencing load shedding at the time. Okay, so this is the example on page. If you want the full lesson on how we have proven this midpoint theorem, you will find it in the description box below. Okay, from last year's lessons. Okay, so this is the example on page. Example on page 249. So here we are told that calculate the midpoint of line segment joining A, which is -1 and -1, and B, which is -3 and 8. Okay, so you must calculate the midpoint. So if you are asked to calculate the midpoint, what's the midpoint formula? x1 plus x2 over 2, y1 plus y2 over 2. Or we have xa plus xb over 2, ya plus yb over 2. Okay. So to calculate the midpoint, if this is coordinates b, that will be xb and yb, xa and yb. You see that people? What do we have? The midpoint will simply be xa is -11 and -1 plus -3, which is -3 over 2. Not so? And then ya, which is -1 plus 8 over 2. So the midpoint will simply be -4 over 2, which is -2, and that is going to give you 7 over 2. People, if you look at where this coordinate of M is lying, okay, can you see? So the negative part of your x-axis, which confirms that negative there is correct, and this is only positive part of your y-axis, which also confirms that it is correct. Okay, so analytical geometry can make somewhat of sense. You can see if you're right or wrong from the diagram itself. Okay, do you guys understand? Any confusion? No? This is the next example, and this example is on page? Sorry? Same page. So here we are told to determine the value of x and y if C is -1 and 2 is the midpoint. Now here we are given the midpoint. Not so? So that means to say we must work in converse or reverse. Not so? So we are given 4 and D, which is -3 and -4, and E, which is x and y. So they draw a Cartesian plane and plot the points given. So that's what they do. Okay. So now looking at this here, we know when we use that formula, the midpoint, which is xd plus xe over 2 and yd plus ye over 2. When I actually do this calculation, what do I get in it as the answer? We get the coordinates of what? Of the midpoint. So in other words, this is x mid and that is y mid. The x value of the midpoint and the y value of the midpoint. Not so. So I take that in account, and that means to say that xa plus xb, these are the terminal points, which is the end points. Can you see that? Divided by 2, I'll get the x midpoint. Not so? And on the other end, we have y8 plus yb over 2 will give you the y value of the midpoint. You all agree with that? So now with that in mind, I tackle the sum here. So that is going to be your x midpoint, and that's going to be your y midpoint. So if this is xe and ye, this will be xd and yd. And this should be x, m and ym. So that's now your midpoints given to you. You guys understand? So what is xd? Just remember, I'm going with that formula xd plus xe over 2 is equal to x mid. Huh? That's what we're going with. And yd plus ye over 2 is equal to y mid. I'm going with this in mind. Okay? So xd is what? So you got negative 3 plus xe. What's xe? X over 2 is equal to negative 1. So what do you see now? The equation. So we can solve the equation here. Not so? On the other end, yd negative 4 plus y over 2 is equal to negative. Another equation. What do? I put this naturally over 1 and I cross multiply. Negative 3 plus x times 1, negative 3 plus x. What is 2 times negative 1? Negative 2. So x is equal to negative 2 plus 3, which is? Okay. And on the other end, again we cross multiply here. So negative 4 plus y times 1, negative 4 plus 1. 2 times negative 2, negative 4. So y is equal to negative 4 plus 4. Therefore, E will be 1 and 0. Can you see that, people? As you can see, this is on your positive part of your x-axis, and that is on your x-axis, which makes y 0. Okay, does it make sense to you? Anybody that's confused? Okay. Now let's go to the next example. The next example is on page 250. What don't you understand? Sorry? Of yesterday's video. Sorry? Yesterday, yes? You didn't understand? Why? Did I explain?
You don't answer every question.
Okay. So let's look at this one here. We are told that ABCD is a parallelogram. So if ABCD is a parallelogram, what do we know? We know 4 things. 2 pairs of opposite sides are equal. 2 pairs of opposite sides are parallel. 2 pairs of opposite angles are equal. Diagonals bisect each other. What do you mean to say? It's the midpoint technique. Can you see that? We are told that ABCD is a parallelogram with vertices A, which is 2 and 3, B, which is 7 and negative 5, C, which is 3 and negative 11, and D, which is XD and YD. Calculate the coordinates of D. Again, there's 2 ways of doing it. Okay? So I'll do both ways for you. With you. So yesterday, when we worked out the midpoint, okay, we can work out M, not so, the coordinates of M, which is the midpoint, as we know those lengths are equal. Not so. And how are we going to work out the midpoint? Using the midpoint formula. Not so. What is the midpoint formula? The midpoint is going to be XA plus XC over 2. Why am I now going with XB? Firstly, that is where B lies. So if you're going to work out the midpoint, it will be that point B. Okay? Which is not what we're interested in. We want the midpoint of that line. Can you see that? On the other hand, we couldn't have used D and B because D is also unknown. You guys understand? So I have to go with AC. Okay. So if you want, you can write A's coordinate here. A, which is 2 and 3, and C is 3 and negative 1. Okay. Sorry? Negative 11. Okay. So that's going to be XA plus XC over 2 and YA plus YC over 2. Okay. So we've got the midpoint. So XA is 2 plus 3 over 2. And then YA is 3 plus negative 11 over 2. So the M value or the coordinates of M is 2 plus 3 is 5, so it's 5 over 2, and 3 minus 11, which is negative 8 over 2, which is negative 4. So M is 5 over 2 and negative 4. What do you notice? I didn't give a reason. Okay?
Yes, sir.
Don't need a reason in analytical geometry as well as trigonometry. Okay? Even if the question says with reason, then you must say diagonals are before and so on. Okay? Right. Any confusion so far? No. Then, to calculate, remember they want the coordinates of D. So now we use the line DB, DMB. Not so? What do I have now? I have D, which is X and Y. I got M, which is 5 over 2 and negative 4. And I got B, which is 7 and minus 5. Do I have to write that on the side, people? No, we don't have. Okay. So if we given the midpoint, we use the formula there. XD plus XB over 2 is equal to X mid. The X value of the midpoint. And on the other hand, we have YD plus YB over 2. It's going to give you Y mid. Okay. So XD is what? X. That's XD, YD. XM, YM. XB, YB. Okay. So XD, X plus 7 over 2 is equal to 5 over 2. The other hand we have Y plus negative 5 over 2 is equal to, or I could have written Y minus 5 is the same. Right, you guys understand? So what do I do now? Cross multiply. So X plus 7 times 2 is going to give you 2X plus 14 is equal to 2 times 5 is 15. You take it over the equal sign. So 2X is equal to negative 4. X is equal to negative 2. Okay? On the other hand, same story here. As naturally over 1, cross multiply. So 1 multiplied by Y minus 5 y minus 5. 2 multiplied by negative 4?
Negative 8.
Negative 8. They get negative 5 over. So y is equal to 3 or negative 3. Have I answered the question? They want the coordinates of D. So D would be negative 2 and some of this is probably what we got the marks, okay? People, as I said, there's another way of doing it, and this is using transformations. Okay. Okay. So what we do is we draw the triangle, the parallelogram. The least it must be is a parallelogram. So this will work for parallelograms, rhombus, rectangles, and squares. Okay, because all of those are special parallelograms. Can you see that? So as long as it's the least it's a parallelogram, then this will work. Okay. So you got 2 and 3, then we got B, which is 7 and minus 5. Then we got C, which is 3 and minus 11. And we got D, which is X. Now, we're going to use a property of a parallelogram here. And that property is the lengths of the sides. Okay. So we know that this length from there to there is the same length as it is from there to there. Not so? Or in reverse, the same thing. From B to A is the same as from C to D. Why? The two pairs of opposite sides are equal in a parallelogram. Okay. So, what is the distance from 2 till 7? 5. And if I move along this, if I'm moving along my X or my Y? X is horizontal movement. Not so? So it's X. So how many units is it from 2 till 7? 5. So how much must this be? 5. So in this direction, am I adding or subtracting? Subtracting. So 3 minus 5? Negative. Can you see that, people? Now when I move along this side, am I affecting my X or my Y? Your Y. Okay, so if I move from minus 5 to negative 11, I'm going down by 6 units. Not so? So if I move from here to here, how many units must I go down by? Negative 6. So you got 3 minus 6. Negative 3. That was the same as the previous. Easy. Are you going to get the same amount of marks? Yes. From these 4 marks. 4 marks.
So you just prove that space.
Yes, and you get it right.
You don't need any reasons.
No, not Euclidean geometry. Okay. Do you guys understand? Really simple. Right. So that basically brings us to the end of the examples for exercise 11.3. You should be able to do now 11.3. Okay.
Yes, sir. Yeah,